perceive time as a river, a steady, inexorable flow that carries us all at the same speed, from the cradle to the grave. But this perception is a lie. Time is not a rigid backdrop to the universe. It is malleable. It is elastic. It is personal. Meet Sergei Krikalev. To the casual observer, he is a cosmonaut. But to a physicist, he is something far more profound, the world's greatest human time traveler. Over the course of 803 days in orbit, traveling at 17,000 miles per hour, Sergei traveled 0.02 seconds into his own future. He is, quite literally, younger than he should be. To understand how, we must dismantle your intuition and step into the architecture of the cosmos. In 1905, Albert Einstein shattered physics with a single postulate. The speed of light, denoted as c, is the cosmic speed limit. It is constant, no matter how fast you are moving. Imagine you are in a vehicle chasing a beam of light. Common sense says you should catch up, but the universe forbids this. The light beam always recedes from you at the same speed. So, if the speed of light cannot change, something else must give way. That something is time itself. This is velocity time dilation. Think of it as a budget. You move through the 4 dimensions of space-time at a constant speed, the speed of light. If you use up your budget moving rapidly through space, you have less budget left to move through time. The faster you move through space, the slower you move through time. Consider the famous twin paradox. One twin stays on Earth. The other boards a ship capable of reaching 90% of the speed of light. For the traveler, the journey to a nearby star feels like a mere few years. They read books, they sleep, they eat. Their biological clock ticks normally. But upon return, they find their sibling has aged decades. The traveler has skipped the intervening years of Earth's history. They have jumped into the future. This is not a hallucination. It is the mathematical certainty of special relativity. But speed is not the only thief of time. 10 years after his first discovery, Einstein realized that gravity also bends the clock. Matter tells space how to curve. Space tells matter how to move. And where space curves, time drags. The closer you are to a massive object, a planet, a star, the slower time flows. Your feet are aging slightly slower than your head, simply because they are closer to the Earth's core. You might think this is purely theoretical. It is not. Your daily life depends on it. Consider the GPS satellites orbiting 20,000 kilometers above us. They are subject to a war between speed and gravity. Because they move fast, special relativity says they should tick slower by 7 microseconds a day. But because they are far from Earth's heavy gravity, general relativity says they should tick faster by 45 microseconds a day. The net result? Satellite clocks tick fast by 38 microseconds every single day. If engineers did not program Einstein's equations into these satellites, the entire global positioning system would drift by 10 kilometers every day. Google Maps would fail within minutes. But what happens if we take this to the absolute extreme? What if we travel to a place where gravity is infinite, the event horizon of a black hole? Here, the curvature of space-time is so severe that time doesn't just slow down. It nearly stops relative to the outside universe. An hour spent in this gravity well could equate to 7 years back on Earth. You could orbit for a week and return to find civilizations risen and fallen, your loved ones long turned to dust. Time is not the ticking of a clock. It is a coordinate, a landscape we traverse. We are all time travelers, marching forward at a steady pace of 1 second per second. But thanks to physics, we know the path is not fixed. Whether through the speed of our rockets or the gravity of the worlds we explore, we have found the keys to the 4th dimension. We can bend time. We just haven't learned how to turn it back. Not yet.